Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. To convert an alkene, cyclohexene, to an alcohol, cyclohexanol, we need to add water across the double bond, hydration. The key question is which method achieves this conveniently and with the correct regiochemistry. Moving on to the next step. In hydroboration oxidation, BH3 adds across the double bond of cyclohexene in an anti-Markovnikov, SYN fashion. The boron attaches to the less hindered carbon. Subsequent oxidation with H2O2 now H replaces the B-C bond with an OH bond with retention of configuration, ultimately giving cyclohexanol. Moving on to the next step. Hydroboration, using BH3 or B2H6, followed by oxidation, H2O2 now H, is a well-established, convenient two-step method to convert alkenes to alcohols. For cyclohexene, a symmetric alkene, this gives cyclohexanol in good yield. And for the final step, A, now H plus H2O, now H is a base nucleophile used for substitution or elimination reactions. It does not add across an alkene double bond under normal conditions. B, Br2H2O, this would give bromohydrin, a halohydrin, not a simple alcohol, cyclohexanol. The product would be trans-2-bromocyclohexanol, not cyclohexanol. D, hydroboration hydrolysis. Hydrolysis of the C-B bond does not occur under simple hydrolytic conditions. Oxidation, not hydrolysis, is required to convert the organoborane to an alcohol. Hydroboration hydrolysis is not a standard or convenient method for alcohol synthesis from alkenes. Therefore, the correct answer is C. Therefore, the correct answer is option C.